of 2-chloroacetophenone, 4-alpha-3-tiosimecarbazone, weight loss, SAM, and DFT studies. Okay, I'm Dr. Nur Nadia Dzulkifli from Universiti Teknologi Mara, Kuala Pilah Campus, Negeri Sembilan Branch, Malaysia. Okay, for introductions, we know that corrosion is a slow process, but it continues decomposition of metal caused by chemical or electrochemical reactions to the environment. Okay, steel is a type of carbon steels that have that contains a low carbon content that often used as construction materials, which is show a low corrosion resistance. That's why we need to apply a protective film as a protective layer on the master surface to inhibit the corrosion rate. Okay. Corrosion inhibitor is the most efficient and practical method of protection on the master surface that being used in the corrosion media. That's why absorption process will be occur in between master surface and electrolyte to by absorption process to inhibit the corrosion rate from the acidic media. Okay, the problem statement for my study is mostly industrial sectors using strong acids such as hydrochloric acid and sulfuric acid for acid cleaning to remove any unwanted scale and rust. That's why the unwanted scale and rust will pollute the environment because it is really hazardous waste for the massive corrosion that contaminate the air and water. That's why this research has significant because corrosion inhibitor give a great benefits to environments. Mostly organic ligands can work effectively as corrosion inhibitor due to its easy production. For example, tiosimecarbazone, it also do not require any specific instrument to produce the inhibitor. Okay, for objective to synthesize the ligands or corrosion inhibitor. After that, we need to characterize the compound to confirm the structure will successfully produced by elemental analyzer, FDIR, NMR, and UV visible. Besides that, we need to study the corrosion inhibition performance, the basic one by weight loss method, morphological study by SAM and DFT study. Okay, for literature review, Amir and Hamis 2000 reported that tiosimecarbazone is one of the shear-based ligands that produced by a condensation process by using carbonic compound such as aldehyde or ketone with tiosimecarbazole derivative in the presence of acids. Besides that, Lobana et al. 2009 report that the nitrogen and sulfur atom in the tiosimecarbazole structures actually accountable for enhancing the corrosion resistance efficiency. So my student Hazani et al. 2018, most of the effective corrosion inhibitors are the organic inhibitors because organic inhibitors compound contain a heteroatom like sulfur, nitrogen, and oxygen having free lone pair electrons with the presence of aromatic ring in the structure. Because additional informations for heteroatom that have lone pair, aromatic have the double bond. The heteroatoms and double bond act as a active site. Active sites mean it will be donate electron to the master surface that containing ferro ions, then form allostatic or covalent bond. So the form then hence resulting the formation of a protective layer. Okay, of course, firstly we need to synthesize the corrosion inhibitor. So by a condensation method, produce the yellow precipitate. After that, we'll do the corrosion study by a basic method, weight loss method. For the morphological surface analysis, we use SAM analysis, and we also do the theoretical, the basic one, DFT. Okay, for this, the chloroacetophenone for active tiosimecarbazole, we see that here has sulfur and nitrogen atoms that as an active site to coordinate with the master surface to form the coordination bond. Okay, For the physical chemical analysis, here we need to analyze the elemental analysis to confirm the number of carbon, hydrogen, and nitrogen and sulfur atoms in the structure. For FDIR analysis, the main functional group that we need to know that either our ligand is successfully or unsuccessfully formed by the absence of C-double-bond-O. Okay, for the raw materials, 2-chloroacetophenone contain the C-double-bond-O ketone. So after the formation of ligand of inhibitor, C-double-bond-O functional group will be absent in the ligand spectra, but a few stretchy bands are formed, which is C-double-bond-N. Okay, for carbon and hydrogen NMR analysis, or the functional or the environment carbon and hydrogen in the amide ligands inhibitor is as meet what is what we are proposed. Okay, UV visible analysis. Here we see that show two electronic transition, which are pi to pi star and to pi star. Okay, for corrosion inhibition study by wet loss method, here we compare two type of acid, which is hydrochloric acid and sulfuric acid. Okay, we choose 195 ppm only for the basic one studies. So here we can the data we can see that when the concentrations of inhibitor increasing, so the corrosion rate will be decreased, but inhibition efficiency will be increased. So here we can conclude that our inhibitor show a good inhibitor performance in HCl than H2SO4. We know that H2SO4 contribute to more proton that contribute to corrosion rate. So means H2SO4 is more corrosive nida compared to HCl. That's why our ligand show a good inhibitor performance in HCl compared to sulfuric acid. Okay. For the SEM analysis, for the morphological analysis, we choose the highest concentration, which is 5 ppm to run SEM. We have run blank and HCl plus 5 ppm inhibitor. Okay, the exposure of mycel surface in H2SO4 was severely damaged compared to 1 molarity HCl blank due to the corrosion process. As a large, here we can see that a large number of peaks with various size and large depth were seen distributed around the surface compared to HCl. After addition of 5 ppm of inhibitor concentration into the corrosive solution, it can be seen here. The damage on the mycel surface was significantly reduced as the peaks and cracks were not as aggressive as the previous as the blank. So we can conclude that through by this SEM analysis, the presence of inhibitor can improve the surface morphology of mycin and that it is effective as a corrosion inhibitor by absorption process. So here we can see that our ligands, our inhibitor form an absorption layer, a protective layer on the mycin surface to inhibit the corrosion rate. Okay, for the density functional group, we want to know which active site that contribute to donate electron to mycin. Here the LUMO was almost homogeneously distributed along the thyroidal moiety. Here the thyroidal moiety, the HOMO density distributed here. The HOMO was found to be mostly concentrated on the thion part C-double-S. Okay, different LUMO and HOMO energy is low, that the electronic transition of molecule from HOMO to LUMO has greater reactivity, indicating that our my inhibitor has potential to donate electron from thyroidal moiety and thion part C-double-S to the on the mycin surface that containing ferrum ions. Okay, for here, the MEP for the region of negative potential characterized by the dark red color, high electron density around the benzene ring, which also is responsible for electrophile interactions. It has tendency to donate the electron to metal ferrum on the mycin surface to form allostatic interaction or bonding. Okay, here are a few data. The ionization potential of inhibitor, which is clearly indicates that it has the tendency to donate electrons. Meanwhile, the electronic chemical potential show low value of negative 0.25365, which represents the stability of the compound. The higher is electronic chemical potential, the less stable or reactive the molecule, because actually lack of studies on the DFT, thiocyanate DFTs. So that's why we find the previous study, they almost send our study, so we can compare the values of HOMO, LUMO, and ionization potential. Okay, so here conclusion, our inhibitor 2-chloroacetophenol for 83 thiocyanate carbazone was successfully synthesized, and the proposed structure was supported by using elemental analysis, FTIR, UV visible, and NMR spectroscopies. By weight loss study, as the inhibitor concentration increased, the corrosion inhibition efficiency of course also increased. The inhibitor was able to inhibit anti-corrosion activity on the micelle, as it provided better corrosion inhibition performance in one molarity HCl compared to one sulfuric acid. For the DFT data, it can be concluded that the inhibitor has the probability to absorb on the micelle surface through aromatic rate and area moiety. Okay, thank you. That's all from my slide, my presentation. Thank you, Chairperson.